That was good. I got that notice.
It was pretty loud.
Oh, I could leave the meeting. Bye.
Oh, that was quick. Lots of people are coming in now. So we have just over 200 participants so far, Gord and Toby. We got 63 that came on just now. We got lots of people are starting to come on. About a third of the way.
Yeah, I don't recognize too many names here, a few.
Yeah. See some BKC people.
Mhm.
Oh, got some Membridge. Oh, that's nice when they put their address at the end that they're from Toronto. That's nice. Thank you. You guys have lots to talk about today. I hope you have lots of water.
You know me, Stacy. I always have lots to talk about. Sorry about that.
The trick is to keep it to an hour and a half.
Right.
Yeah, we still got. So Gord, if you want to just put up your starter slide there, I think we're getting a little bit closer.
For sure.
Thank you. That way people will know they're coming on to the right
The right
session.
place.
Yeah.
This is not the Amway session.
No. All right. Thank you, Leo.
Who all did this go out to, Stacy? Do you know, in terms of advertising it?
Yeah, the marketing company that Building Knowledge employs has a list that gets built upon after each session, and then it just gets bigger as more people want to know about it and sign up for the newsletters and get directed to the website. So it goes out to quite a few people. So Leo in the chat just said he's from BC, so that's great. We've got some from Toronto. We're still waiting on quite a few more people.
Just stop sharing there just for a moment. My apologies.
Chances are they won't all be attending.
And
so we will be polling everyone to find out where you're all from, so you don't have to put it in the chat if you want to wait till that time. and that way we can get a feel for it all at the same time. But thank you.
And I'm having I can't really see the chat now that I'm in presentation mode. So Stacy, I'll rely on you to let me know if there's anything.
Sure.
I'll keep an eye on it too, Gord.
Yeah.
I can have the Q&A open as well. Questions.
Sure.
Yeah, we're starting to feel spring here. I wonder what it's like for everyone else.
Yeah, we had a real taste of it there in the weekend, didn't we?
We did. We have a dog that's very excited for the spring.
It's funny, they get excited when the first snowfall, and then they get excited when all of a sudden they can see grass again.
Yeah. Well, it's not good for a dog owner if you're the one cleaning up after them, right?
Oh, absolutely.
Oh, it's 0. 20 centimeters coming for Saturday from Nathaniel, Quebec. That makes sense. So as more and more people are coming on and making comments, if it's anything relevant that you want to make a comment about, save that for the Q&A. We'll get to those a little further into the presentation, but it's easier for Toby and Gord to see those questions if they're in the Q&A. Yes, you are all on mute because we can't have over 200 people all trying to talk over each other. Sorry about that. But if you have a specific question, yes, put that in the Q&A and we'll get to that. Paul Dennis is just mentioning your name on the Q&A. Gord, making sure you can see it, I guess.
Great. Thanks, Paul. Nice to see your name.
There we go. Thanks, Toby.
No problem.
Good practice for us. Thanks, Paul. So that way we know we've answered the questions.
Probably get started, shouldn't we?
If you're okay starting with, you just over half the participants are here right now, but they're the ones who showed up on time, so.
There you go. So Stacy, start us off.
Okay, well, welcome everyone. My name is Stacy Cooper. This is my first moderator session today with the lovely Gord Cooke and Toby Smith. And we'll be talking about the top 5 building science and energy efficiency priorities when renovating Canadian homes. And Gord and Toby are going to talk about all those critical building science principles. Gord, as most of you should know, he is the principal of Building Knowledge Canada with over 35 years experience. And Toby comes to us with over 20 years experience helping professional renovators improve their performance of existing houses. So that's them in a nutshell. As always, we'd like to thank our sponsor, Enbridge, and Susan Cudahy sends her regards today. She's unable to make it. She's needed elsewhere. And she comes from us from Enbridge Gas. She's the supervisor of the strategic builder relationships, and she supervises the team across Ontario here. And so thank you, Enbridge Gas, for your continued support in what we do here.
And I will say, if there are Enbridge folks on the call, maybe identify yourself in the chat or Q&A. Kind of like to refer to you. Stacy, I think, you and I have been in the industry a long time. Enbridge has always been a great partner in the industry. I always like to say, years and years ago, I met Susan when she was at the Legacy Company Union. And I would say, are you sure you're comfortable with helping people use less of the product you sell? I mean, it's kind of an interesting idea, right? That as a sales guy, that's not typically what I would be used to, but it's so cool that Enbridge is a partner in the industry trying to help us use their product wisely. I think Really cool.
So as always, we have rules of engagement when we participate in these webinars. The Q&As, if you want them to be answered and for Gord and Toby to be able to see them quickly, putting them in the Q&A is always best. And the chat is really just to maybe say hi to someone over in BC, or to say that you're looking into something that's not really as relevant to the webinar we're doing here today. And then I'll be in the background once my face disappears here, just checking things out, making sure no one's having any technical difficulties. And then I do encourage you at the end, I'll be sending a follow-up email with everything about this webinar with a SurveyMonkey link that just helps us improve our whatever we've done here today. And Enbridge Gas really likes to have that feedback so they can look at what else you might want to hear about. And then everything goes out either today or tomorrow, and you'll have everything that Gord and Toby talked about here today. And then that's our timeline. We like to wrap up here right around 2:30. So at the 1 hour and 15-minute mark, we will be giving you guys the roundup. We're going to finish off with as many questions as we can near the end, and try and get you guys out of here in an hour and a half. So we're going to launch our first poll today. Just our basic quick one. We want to know where you all are located. So give you a minute to start answering that poll. Pick out your province, wherever you're from. Oh, you guys are fast. We might get them all in this exact time frame here. Lots from Ontario, no surprise there. Okay, I'm going to end it in 5, 4, 3, 2, and 1. And
oh, pretty cool.
Lots of people from Ontario.
Yeah, BC, welcome.
Nice to see,
Alberta.
I was just in Edmonton, so nice to see a few folks there. That's wonderful.
And some from the US, so thank you. All right, and then our next one, we just want to know what you guys do for a living. So let's hear what your occupations are. Hopefully we've grabbed enough of them. We're in the right category. Try not to have so many in the other category, so we might have to switch those up if we aren't getting enough. Yeah, so nobody from the site staff part of things.
We're just doing
great.
we're just developing sessions, Stacy, both ends of the country, BC and New Brunswick, for real estate agents, and so curious to see if anybody would identify themselves as maybe it's under sales rep, but it'd be interesting to see.
Okay, I'm going to end the poll in 5, 4, 3, 2, and 1. Okay.
Oh, lots of people reporting in the chat, because I think it says tell them in the chat. So property managers, there's sales rep, advisors, windows.
Lots of others. That's interesting. We need to expand that category. That's one to add, Stacy, is property manager, it looks like.
Okay, good. Well, it only lets you do 10 choices, which is why you end up having to do other for.
I guess this session too, we've said builder, but some would say, well, I'm a renovator, not a builder. So that's perhaps a thought too.
Okay, I will add those. Thanks, everyone.
And thanks everybody for being on the call. Hopefully we get you the information you need. You will know that, oh, there it is there.
Yep.
Can you close that off again?
Yep, we're all done.
Oh, why didn't it close off of mine? Oh, there we go. Okay, there we go. So as Stacy mentioned, we thought we'd tackle renovation. What can you get done as we're renovating houses? And you know we have to be renovating houses. It's a big issue for us, and we need to think about a little bit of urgency of the energy efficiency initiatives in existing houses. And let's talk about the common renovation priorities, let's say in your clients' minds, in your homeowners' minds, but making sure we're touching back on the building science side. We always say our job is to help you avoid risks and to optimize your opportunities. So in that respect, then how do we match those two up? How do we take the renovation projects that people want to do and put them side by side in terms of the building science priorities to match them up, to make sure that we don't have unintended consequences, to make sure we're taking best advantage, and frankly, to open up opportunities for you folks for more work. So keeping that in mind. And let's start with that urgency idea. You know, this is pretty interesting information. I was able to pick it up in less than 10 minutes off the internet. There's our housing stock in Canada. Down at the bottom there on the left-hand side, roughly, as of 2015, 15 million houses in Canada. Now, of course, in the 6 years since, we've built another million houses. That is 200,000 a year, 1.2 extra. But notice that big chunk of houses built in the 60s through the 90s, if you will. It creates this big bulk of houses. And what's really pretty interesting, Canada's done a pretty good job of energy efficiency. If you look on the chart on the right-hand side, I'll use the gigajoules per household, using the metric on the left-hand side, that we've seen a really nice reduction in energy use per household from 1990 to 2015, 2017, about 28% reduction per household. And that's including the fact that we live in bigger houses, we take more showers than ever before, we use more air conditioning than ever before, we have more appliances than ever before, and even still, per household, we've seen a 28% reduction in energy use. And so we're building bigger, more complicated houses. We're still seeing a nice improvement based on all of the work that's been done by governments, industry, utilities such as Enbridge with their utility programs to try to encourage people to save energy. It's a pretty good number. Toby, I think you will say you've seen efforts or evidence of this in the work that you've done, but it's kind of nice to see it in a graphical form.
Yeah, doing one project at a time, kind of, you don't really see these results.
And what's really cool, though, or really important to understand, is we're still at about 100 gigajoules or more per household, 100 gigajoules per household. We've done this really nice job of coming down from 140 to 150, and that's a nice reduction. But when you think about zero energy construction, which Toby, you and I are often talking about in these sessions, we got 100 gigajoules yet to go. And what we want to talk about today is just how practical is that? Can we actually get there is really the key. So I just put it in sort of pictorial form. There's the sort of classic before 1946, the double wide brick. What can we do with that? The 50s to 60s, the houses that I would say guys at my age grew up in. The houses built, a huge slug of houses built just after the war. Those, sort of squat ranch bungalows, whatever you want to call them. Then in the left, we started going up a little bit in the 70s and 80s, and attached garages, bigger footprints. I'm not showing any multis here, and you guys would know that we're doing now 60% of what Canada builds as new construction is multifamily in some shape or form. But there's the big urban setting, 90s to or suburban setting, I guess, the 90s and the year 2000s. And again, I'm restricting conversations here to kind of 2015 at latest. We're assuming those aren't real candidates for renovation, although they may be. And so what we always like to ask, what are the typical renovation projects in these kinds of houses? Toby, in your own case, you bought a house. What was top of the list when you bought your house?
Well, we, top of the list really was kitchen and sort of those aesthetic things, but then reality set in and we had, leaks in our roof that were causing water damage. We had a furnace that broke down. At some point, we've also had, kind of aesthetic things, flooring that is totally, needs to be replaced, is so, original to the house. So those kind of things tend to creep out and become the priority over just,
I often get asked, what is the expected life of a house? And building codes are written around the idea across North America. Building codes are written around the idea of a serviceable life of 75 to 100 years. That a house, yes, we need some new flooring, and yeah, we're going to need a mechanical. But in general, and of course, the Europeans would say, what are you talking about 100 years? They should be 500 years. In Germany, you can get a 100-year mortgage, for heaven's sakes, a generational mortgage. So, but in other places in the world, I was in Japan, and that part of Japan, the average life expectancy was only 30 years at that time because of tsunamis and land use changes, the population growth. They knew that people would be tearing stuff down. So in Canada, we're thinking 75 to 100 years. But there you go. There are the kitchens and baths, the basement, the new roof, the windows, maybe an addition. In Newfoundland, they call that an addition add a piece. That's how they describe an addition is add a piece. And as you mentioned, updating finishes and furnishings, and then HVAC replacements. My big question is, what prompts those renovations? And Toby, what's been your experience?
Well, I'm still in my first house, and it's a 1959 or 1960s house. So a lot of it has not been upgraded very well from the previous owner, really at all. So a lot of it is the necessities, like I mentioned. So it's a leaky roof, a broken furnace, windows that blow open, when the wind exceeds a certain speed and stuff like that. So.
Amazing. And what we want to get across today is there's going to be a new prompt. Rightly or wrongly, there's going to be a new prompt. So historically, it's been the 6 months before you sell a house and the 18 months after you move into a new house.
That's it. Yeah.
And that's been the prompt. But now with the Greener Homes program and the municipal programs, the Greener Homes Kingston, Greener Homes Ottawa, Oakville's looking at a program. They're going out to folks and saying, we can't wait till your furnace breaks down. We can't wait till your windows are done. We need you to go a little quicker. And that's really what we want to think about is a new prompt. And this has good news and bad news. It does mean new opportunities for renovators. It also means different things that you need to think about, different timelines and so on. And so I always like to ask, if you're doing the ones on the left, which of these should include an energy efficiency upgrade? And hopefully you'll agree, all of them. Heck, I would even add landscaping to this list. If you're digging around the outside of a house to do landscaping, let's put in some insulation. I would say every one of these items on the left-hand side could include some amount of energy efficiency. You think about tearing out flooring. Is that a chance to caulk along the baseboards as you take out the baseboards along the bottom plates? So in my opinion, everything could be on the energy efficiency upgrade list. The real question is, how do we get to deep energy retrofits? How many of those 15 million houses are we going to take down to 0 gigajoules? And clearly that's not realistic in the next 20 or 30 years. Let's be clear, 2050 is where we need to be significantly different. We got to make some big changes. So let's see how far we can get today, I guess is the question, and move from there. And I thought I'd contrast or use as a bit of a template for today, not to say we're going to get to net zero, but if we looked at kind of the holy grail, what would there be? And a typical net zero house, Toby, you and I have been working with 30 or 40 builders, we got to get to 60 to 70 in the ceilings, 25 to 35 in the walls, 25 to 35 in basements, R10 under slabs, which you're going to go immediately. I can't do that in an existing house. Tri-pane windows and under 1.5 air changes. And then on the mechanical side, we need to think about heat pumps and some measure of efficient backup heat and high efficiency domestic hot water, high efficiency ventilation, drain water, heat recovery, LED lights, Energy Star appliances. And again, not all of these are going to happen all at once, but I want them all on your list. Take a screenshot. Well, we're going to send this to you. I need you to check off which of these you've done in your own house, and how, not when, if you're going to do these, but when, how soon you're going to get these done. Even in my own house, I live in a 1992, I'm here in the kitchen, my 1992 R2000 house, so it's already airtight. But even I'm going, wait a minute, I just put on some more solar panels. I need to change out to a heat pump, so on and so on. We just need to make changes to our priorities. If we're going to meet Canada's commitment, we're just going to have to get this stuff done. So,
Gord, I just wanted to add, because there was a question about deep energy retrofits, and this is the kind of stuff, if you are doing a deep energy retrofit on an existing home, these are the kind of things you have to think about. Yeah.
How far could you get, right? Which of these could you get to? Again, you're not going to get the underslab, well, not in a practical way, but could you do something similar or equivalent to get the same impact? So thank you for that, Toby. That's a good comment. And then ultimately you would add some solar panels because we know people are still taking showers, they're still watching TV, still cooking. So ultimately we still have some occupant loads to think about. So I just wanted to use that as a bit of a template as we move forward. And Toby, here you go. This is your house. Tell us a little bit about the story.
Sure. Well, we bought the house about 6 years ago. Our first house, and it needs some work, like I mentioned. It was pretty much original. At this point, you can see there's a newer garage door, but that's about it. I think one of the bathrooms was updated at one point. Other than that, original cupboards. The roofing has been done, a few times as well. It's 60-year-old house. But after we bought it, that became an issue. Water leaks. We had, leaks. It's interesting finding this stuff out. Leaks under the bathroom upstairs. And so was that caused by the bathroom, or is it caused by the leaks in the roof? And so we had to do a fair amount of investigating and things like that. But our priorities were making a kind of a second living space for my father-in-law in the basement. That was one of our first priorities. And then a lot of it has just been maintenance stuff. So I kind of see that, originally we saw the kitchen and those more aesthetic things as our priority, but reality set in, and, you got to fix the roof, and the windows were really bad. Like I said, we literally had to screw them shut in the wintertime, or else they'd blow open when it got really windy. Furnace broke down, things like that. We tried to keep a focus on lowering our bills and incorporating energy upgrades whenever possible. And I'm sort of biased because that's the business I've been working in. But I do see.
It's a condition of employment. You gotta work
right. Yes, it's on my contract. Yeah.
Yeah, exactly. But you do mention limited budget, and of course, renovators and professionals on this call are going to say, "What about that budget?" Well, this is what's really interesting. You're going to say, "Well, there's the Greener Homes grant," but then there's some really new, cool stuff coming of low interest loans, or is number one, and then some of the communities are doing energy efficiency on tax bills so that you can finance it through your tax bills over time. So I think we are going to see some interesting ideas, and banks and utilities are going to try to help us to get away from that limited budget, because if you had a little more budget, you clearly would have done a little bit.
Yeah, and that's a good point to say that you saw the priorities there, but I think the priorities change, right? So we had to change our kitchen priority, but now some of this financing might make some of those deep retrofits or other changes more feasible.
And of course, you're an energy auditor, and so you advisor, so you did a little pre and post. How did that work out?
Pretty well. We did it in a couple phases. So this is, you can see between 2010, 2016. The 2010 was actually, it was owned by my father-in-law at that point, but we were renting the house, so we were involved in the renovations and stuff with the goal of purchasing it after he moved out. So the ACH, I'll be honest, I'm not really proud of that. Those results, I'd like to see it much tighter, but in all honesty, it was difficult. We replaced all the windows in the house except for the basement. And so those are the ones I was talking about that were blowing open, awning windows where the latch is completely done. The California sliders with the large panes of glass, not very airtight. And that did not register very much airtightness, or very much of an improvement. So we still had to go around and do weather stripping, seal up some penetrations in the header. There was an issue with the newly installed fireplace in the basement as well. The other interesting thing here, so you can see our electricity went down, but our gas actually went up, and that was to save money. Essentially, we had just an electric tank water heater, so we replaced that. My father-in-law made the decision actually to replace that with a gas water heater, which did save us about $40 a month on our bill.
Pretty interesting, Toby, because Up until, as you said, 6 years ago, even 5 years ago, even 3 years ago, we would have said, well, that's a great decision. Overall, you saw an 8% drop in gigajoules, so we're nicely on our way from 108 gigajoules down to 100, and now we got to go further. But historically, we would have said, natural gas is really clean burning, which it is. And now, though, we're thinking about those are fossil fuels, and should we find a way to use those more effectively? So that's a challenge, right, for Enbridge and for everybody on this call to say we have some cost issues here of cost of fuels, which is going to get sorted out, and we really want to reduce the greenhouse gas emissions. Ontario specifically has a really pretty good green grid, as does BC, for those of you on the call. Alberta, not so much, right? Still a lot of coal in your grid. So that might have been a better decision in Alberta. So each one of you in the various provinces are going to have to look at your own utility structure to show what the greenhouse gas emissions are to try to make that best decision. So we're going to have to weigh off the energy savings versus the dollar savings is really what we're at with this one. So nice start, 6 years, not bad, a 6-year improvement. Now we would just say we need to amp it up, ramp it up. What else could we get done, I guess, is where we'd like to get to.
Yeah,
so
those are our new priorities.
Our new priorities, exactly. So I want to start with, we mentioned basement renovations. In your case, this was not your basement, but
similar.
But, just so we're really clear, right? That 1960s, 1970s basement that many of you on this call knew. You played ping pong and had parties and so on. But I need to ask you, can you smell this basement right now? And if the answer is yes, you need to know this was part of a CMHC indoor air quality study. This was a young woman in this house, the daughter, had very severe asthma, ended up in the hospital 6 or 7 times a year. So their motivation was not necessarily energy, but it was when you're doing this was a candidate for indoor air quality, but could we do this? And if I said to you 3 things, there was visible signs of moisture damage on the outside wall, that is spalling of brick and so on, and some efflorescence downstairs. There was a very noticeable smell, and there was a very sick person in the house. Is that enough for you guys to decide to gut the basement? And the answer is it should be. You absolutely, this isn't a lick and a polish and a paint and so on. This is gut it and fix the water issues. And really, Toby, you and I would say you can't do a basement until you first do the water fix. And you would say, well, could I do that from the inside? And sure, we could do some internal drainage and so on. But frankly, you can't insulate until you first fix water. And the best place to insulate is on the outside. The best place to fix water is on the outside. Insulate and water management is on the outside. So this client actually did dig up the outside, and when they dug up there on the right-hand side, they insulated with 3 inches of insulated styrofoam board in this case. And you're going to say, how did they finish it? A stucco coating and so on. And interestingly enough, it did not insulate, at least not initially, on the inside. They put all their insulation on the outside. It made for a really nice, clean basement. They initially didn't finish the basement because they weren't really using it, but now you could imagine finishing that basement. And if I went back a slide, the cost to gut is a dumpster and a few hours, a few weekends of work. The cost to dig up, of course, is 20 to 30, maybe more. What's the incremental cost to insulate? Well, once it's dug up, it's actually not that bad. And they end up with, I just need to be really clear, they end up with a house that cost, this basement renovation was in the order of $50,000. At the same time, they replaced the old oil furnace with a new high efficiency and a heat pump, new windows in the basement, which isn't much, LED lights, and a high efficiency water heater. Now, I'd like to tell you it was a heat pump water heater, but it wasn't. It was a gas water heater, but it was high efficiency because this was done 10 years ago. This is a 10-year-old story. But a $50,000 basement renovation, and the daughter didn't go to the hospital in the ensuing years. Is that worth it? And I think we'd all agree, of course it's worth it. And at the same time, what did they save in terms of energy performance? That's really where we need to get to, is to say I get this added benefit of energy performance. And if you don't want to or can't dig up on the outside, here's a great basement detail. This was studied at the University of Waterloo and University of Minnesota. It was a great basement opportunity. This is extruded polystyrene foam on the walls. Showing spray foam here in the header, doesn't have to be spray foam. The key is extruded polystyrene, just the right permeability. Could be EPS. You don't want it foil face down in this location because that's too impermeable, but an EPS or an XPS. And the key here is, and of course, if you'd say, could I foam the whole wall? Of course, you could foam the whole wall. But from a cost effectiveness standpoint, could we shove some foam in behind? My son and I just redid his basement. The studs were already an inch off the wall, and we simply put an inch of foam that got it because it was moldy. We got it in the basement. Other than we left the studs, we're able to put an inch of foam behind, and then fiberglass. This is showing blown in. It doesn't have to be blown in, but a very effective, cost-effective basement renovation. Notice here, no poly on the basement wall, or we could go to membrane, something like that has some breathability. The key to this wall is any moisture that's coming from the outside. It gets stopped by, it's not watertight, but any moisture capillary flow is stopped by that XPS foam, so it doesn't get in the wall cavity. And any moisture that's coming from the inside, water vapor, rather than condensing on cold concrete, it hits that warm foam. So it's considered to be the best of basement installation methods, and it doesn't add that much in terms of the cost. Well, you're going to say it's an oil-based product, it has gone up in price, which I guess it has, but that inch and a half inch to inch and a half is what I would say. And now you're at effective R20, if you put 2x6, or well, let's do it this way, inch and a half of foam with a 2x4 wall, you're pretty much at R22. You're in that right range as net zero. It's not a bad choice to think about. The big question we always get is, so what do I do with the floor? You know, you want to insulate that slab. You can't unless you're going to chop out the slab. What do I do? Well, you're always worried about losing ceiling height. And the first thing we would say when we were doing CMHC indoor air quality work, they did not want us to put foam directly on the floor. The problem is as watertight as it is, it still can absorb moisture and gaps for microbial growth and so on. So this is, some of you will know, there's 2 or 3 versions of this type of product. Ignore the basement wrap, by the way, on the wall. We would say that's not a great choice. But this becomes a great product. This 3/8 of an inch dimpled layer. Imagine this: if it becomes a great moisture barrier and a soil gas barrier, so it's a great radon choice. It gives you a little bit of an air gap, 3/8 of an inch, that in fact you could ventilate. In fact, this product's used extensively in Europe as a radon barrier, and they actually put a little fan, drill a hole, put a little fan to exhaust air out on a continuous basis to create a subfloor ventilation system. And now you could imagine, now I could go, notwithstanding headroom issues, I could put an inch and a half of foam and then put my subfloor down. And in fact, you will know, many of you will know, you can buy similar type products at big box stores. Now, you guys are pros. I don't want you buying a big box. Go buy it in sheet goods. It's way more cost effective, easier to install, and so on. But you have the idea here that we could come up with that warmer, drier, healthier basement. And that's really what we want to get to, that $50,000 renovation or basement job done for the asthmatic child. Or you could think about a more livable space, or you could think about safer. And depending on, and here's the magic, Toby, you would do an energy model for them and show them, depending on where you are now. I think we're talking, well, a minimum of 3 gigajoules, but as many as 10, maybe even more, right? In an old basement, 10 gigajoules or more.
Yeah, I think we've gotten used to Canada having cold basements, but a lot of lack of insulation there can really reduce your energy consumption for sure, and improve the comfort down there.
And so what we're using here is an excuse to say, if you're doing a basement renovation anyway and going to the trouble, the incremental cost to add this inch and a half of foam on the inside or digging up on the outside, you can say, well, people don't dig up on the outside. Well, some do, and let's not miss that opportunity. That's really the mantra of this session. The real key learning is don't miss an opportunity. I still find clients, many folks that I speak to, homeowners, who will tell me, yeah, my contractor talked me out of it, said it wasn't worth it, there was no payback. It's not about payback in this case. It's about healthier, safer, more durable, and by the way, doing your bit for Canada's energy reduction. Oh, and yes, there's going to be some energy savings. That's the way to look at this. You cannot justify this on energy savings alone, nor should you have to. There's no energy save, there's no dollar savings to granite or bamboo flooring. Those are aesthetics. These are aesthetics, if you will. Beautiful, bright spaces your children can play in without health issues, so on and so on.
And you might even get a bonus a few $1,000s grant from somewhere.
Absolutely. And could we put it on our property taxes to get it financed? Those kinds of issues. Exactly. And then, Toby, you and I've been doing it longer than you, but boy, we've been on this air leakage agenda for over 40 years, right? The slide on the right, or at least the pie chart on the right. I know my brother's house was over 50% of his energy bill, built in 1910, as 50% of his energy bill was air leakage. But with this graphic, in fact, our good friend Gail Lawler had said, does anybody have a new updated version of this graphic? And no, we've been using this one a long time, and it shows all of the normal, typical air leakage spots in houses, and notice air's leaking in at the bottom and out at the top. So air leakage has been on our agenda. Every energy efficiency program ever written in Canada talks about air leakage. But as Toby, you mentioned, it's surprisingly difficult to do, right? It's how do I find them?
Yeah, that's a key. First, how do you find them? And that's something with air leakage test can help with.
Exactly. And so what I want to do is give you the building science rule. And remember this, that with air leakage, I have warm moisture going into cavities. Cavities that are getting colder and colder. The more I insulate walls, the more I insulate attics, the colder those spaces get, the colder the materials to the outside get. What you're seeing here is not because we made houses too tight. I still hear this. I was out in Edmonton. They were telling me about their attic moisture problems, and they were saying it's because we build them too tight. And exactly the opposite is true. Their attics are insulated to R60. There is no forgiveness. There is no ability to forgive in terms of moisture dry out potential. So we all need to, from this day forward, from this session forward, you don't pass this course unless you're able to say, we need houses to be tighter. Forget energy. We need it to make sure that buildings last a long time. And Toby, you and I have seen these. I see it all the time. In the early days, we need to be really clear. In the early days, we thought it was an attic ventilation problem. And yes, there are some houses that have attic ventilation problems. But technically, it's an air leakage issue. Don't let the moisture get in the first place. If it does get in, okay, now I can go ahead and have a small amount of ventilation to let it out. But remember, the colder the attic gets, the less drying potential we have. Let me say that again. The more insulation you have, the less drying potential, and the colder the surfaces. So that's a really important lesson. The bottom, I'll go to the bottom first. You can't insulate unless you first air seal. And back in the day, there was a program, some will remember, called CHIP, Canadian Home Insulation Program, where we paid thousands of contractors, thousands of dollars to blow insulation into hundreds of thousands of attics in Canada. Great. And a few years later, we noticed some problems. When I'm in the US, I lie and say we had a second program called ARP, Attic Remediation Program. Well, it wasn't exactly a program, but we learned that, oops, we need to go and air seal. We first tried it with ventilation, turbines, and Timmins, Ontario because it was so cold, I know it was a big issue. They were all putting turbines. I knew a guy was selling turbines on roofs, and it actually made the problem worse. And up until a few years ago, most have been replaced now, but you could fly over Timmins and you could see all these turbines with plastic bags over them in the wintertime because they realized turbines actually made things worse. So air tightness, and Toby, you and I obviously were in the interest of doing energy advising, but I'm going to say to every renovator on this call, every project you do, because of the focus on health, safety, durability, and yes, energy efficiency, do a blower door test. Just get an energy audit done. It's going to get paid for your client. So call an advisor in your area, somebody you work with that you know, and say, hey, I'd like to include this as part of my service. The feds are going to pay at least part of the fee under the Greener Homes program. And of course, we're tested at 50 pascals. Most of you know that. The nice part is it exaggerates those leaks to get better improvements. Even then, it's still tough to find. But what's nice is you do get to do the before and after comparison. So really nice sense of where things are going. Toby, you've probably done a couple of thousand blower door tests in your career, as have I. What's the worst house you've ever seen?
ACH, I think it was 25.
Yes.
25 ACH, and I had to go back and get a second blower door.
To make it work. My brother's house was similar, 25, 26, and we did some work, and I'll tell you why in a bit, as to why he went ahead and did that tightness test. So we just need to get there. And you're going to say, well, how tight? Well, Well, I would say, well, how tight would you be if you knew where the bugs were coming in? You would say as tight as possible. If you wanted to get rid of dust, how tight would you want it to be? If you wanted to know where the water was coming in, how tight? Where's the noise coming in? How quiet do people want their houses? And of course, how much energy you're wasting. And I need to, guys, all on this call, don't talk about savings. When you're talking air tightness, don't talk about saving. Talk about how much money they're wasting right now. It's far more motivating to talk about waste. Oh, geez, that's a shame. Going to do this great renovation. I really wouldn't want you wasting any money. Let's go ahead and do that blower door test. And so I'm going to say it's looking for holes to seal in every renovation project. You're doing a bathroom, do a blower door test. You're doing a kitchen, do a blower door test. You're doing a landscaping project, do a blower door test. You're going to go, you're crazy. No, I'm saying to you, every project should have a blower door test as part of it. And of course, we're going to find some big holes. The one there in the middle I'd like to show you because that was 21 of 42 townhouses. One's on the one side of the street versus the other side of the street. And almost all of the 21, this was up in the attic, and they were having tremendous moisture problems in the attic. It was a chase that was built slightly differently, and there was this chase in behind the tub that never got sealed. The poly fell down, and now they had this massive leak. Look at the one on the right. This was somebody was doing a renovation of a bathroom, and we would say always pull the tub. Here's why. Look at the big hole to the outside, and the return air duct was actually at the other side of the tub. So the return air was nicely pulling fresh air. It's like your own little private ERV, HRV in your bathroom. So we always say to renovators, pull the bathtub, pull anything that's on that outside wall. Really, really important. In every renovation project, look for the big holes. And Toby, it's kind of instructive. People think there's going to be some magic smoke pencil or something, but typically we're just using our experience in our hands to figure out where the leaks are.
Yeah, sometimes it can be a little tricky. We know that air, like water, will take the easiest path, and sometimes it's not always a straightforward path. So I've seen pretty often where you have a lot of leakage into the floors, actually, just in one last week. And that presents then whenever you have a penetration in the floor. So that could be as simple as, old floorboards with cracks in them, or plumbing going through the floor, or pot lights from below, or whatever it is. And those can be, that's air from outside through the header or through another roof or something that's on the house. I'll actually show, I think, another picture of my house later that could give you an idea of those issues.
And that becomes the leakage pathways. Making it tougher for the air to leak through those pathways is important. And it does point out the question, so what is the air barrier in that old house? What is the air barrier? That double wide brick wall, what was the air barrier? Well, probably the plaster on the inside. Is that okay? Absolutely. Plaster is a fine air barrier. So now I'm just going to seal the penetrations through the plaster, or I'm going to try to find a new air barrier. Maybe I'm going to treat it from the outside. Maybe I'm just going to put stucco over top of the old brick, so on and so on. So we need to identify with that blower door test what was the intended air barrier, not vapor barrier. Don't worry about vapor barriers. Think about what was the intended air barrier. And wood's a good air barrier. Drywall's a good air barrier. All of these are all the materials that you build your houses that are effectively air barriers. We just need to find a way to connect the dots. We're not talking about going up into an attic and running poly all over the place. No, the drywall that you're looking down at is a fine air barrier. Just seal the penetrations. Below that is what's key. And then the question is, in new housing, of course, we want you to get tighter, tightest. We know the net zero level's under 1.5. But what is a reasonable number? And Toby, I'll ask you to speak to this. Is that a reasonable improvement? My brother's house was 26. How good am I going to get it?
It really depends on where you're starting at. A house that's 26 is going to have some large air leaks, right? Like many square inches, 5, 10, 15 square inches on a single location, probably. So if you're starting that leaky, then, 50% might be a reasonable improvement. Just going back to my place, starting around, I think it was just over 5 air changes or 6 air changes. It was tough to get that reduction, and we're at a point now where we need to do more. We need to do some more a deep energy retrofit. We can't get to those leaks that are inside the floor between the two levels or wherever they are.
Yep.
And there are, if you are doing deep energy retrofits, there are newer technologies now like aero barrier that can help with that if you're doing a large scale reno. So basically it kind of gets tougher as the house gets tighter, but that's a definitely reasonable target. Yeah.
And most energy programs are looking for at least 25%. Is that right?
Well, the greener homes one is dependent on the Hot 2000 target that's calculated. So it varies. And again, it varies on how leaky the house is to begin with. And so it can be anywhere from 10 to 50%, somewhere there.
And here's what I would say, pros on this call. Use this term, blower door directed air sealing. That is, the energy advisor is going to come, do a blower door test. Once you start doing work, hire them again to come out and put the blower door on the house so you can find the holes. Blower door directed air tightness testing, rather than just caulking around baseboards and caulking around electrical outlets. They may or may not be leaking. Let's use the blower door to find the holes. You're going to find you're way more cost effective. This is work that came out of the US, Wisconsin, the Wisconsin Energy Conservation Program. They did weatherization, and they always required blower door directed. And there's some great companies out there, Great Northern Insulation and others, that do this, that as part of their insulation strategy, they will bring the blower door and find those leaks while they're doing the work. So keep that in mind. And I just thought I'd give you a sense of, if I go from 3 air changes to 1.5 air changes, I'm saving about 9 gigajoules. That's pretty interesting. Even on a house that's relatively tight, if I can get it down to to net zero levels, I'm saving 9 gigajoules. So it's a pretty important number that we need to think about in houses. And I'll use a little example. This is my neighbor across the street from where I am now. They were doing a kitchen reno. And I was trying to tell them, you see those valance boxes over the kitchen cabinets? I said, Jeremy, you should really tear those down. It's going to be too expensive. There's nothing back there. I said, nah. So I did a blower door test and found it was a pretty leaky house. And then it started to come to forward. He goes, well, yeah, we have a lot of mice and a lot of bugs too. So in fact, the major reason for this renovation, in fact, the only reason for this renovation, see that annoying column? That had been there. There'd been a mistake when the house was built in 1990. They'd undersized the beam. At the last minute realized it. And in this rather lovely house in a lovely neighborhood, they ended up with this column. And they spent the next 30 years going, how do I get rid of the column? So they finally have enough money. He's an airline pilot. And he said, okay, we're going to do it. So in fact, the major point of the whole renovation was to get rid of the column. Okay. And in fact, when you think about this house, there was that classic brick and on the bottom, siding on the top. And what do? We overhang the siding, which leaves a 4-inch gap. And in that 4-inch gap, I said to them, that's where the air leak was coming in. I could feel it coming out of kitchen cabinets and so on. So in fact, they did gut that. And here's what they found. 20 years of mice activity. It was just a perfect place for mice because the food was right nearby. The kitchen was right there. They had no less than 10 wasp nests had been built in different sections. And Jeremy goes, oh, that's where they're coming from? They also found that illegal electrical connection, no air barrier up in the rim joist at all, and very ineffective insulation. So it's just a kitchen reno, but for a few extra bucks, because what did it really cost? They were going to take out the cabinets anyway. They were going to take out, they weren't necessarily going to do the drywall, but what does it cost to take out drywall and redo it? And you can imagine that was really simple to fix. Now they did some other things as well, but just a little bit of handy foam. What's that? What's the froth packs that you can buy? That they could have done those rim joists and done a nice job. And the result, look at that, no column, beautiful. They also did a triple glazed patio door. Okay, it's just one window. And again, well, we're not changing all the windows, but are you going to change the windows at some point? Well, yeah, we're going to do the other windows too. Well, then let's do this one now. So the 3 windows, the 2 that you see there in the back of the picture, and those were replaced, and the patio door. So they did those. They did LED lights and new Energy Star appliances. So they get the benefit of no column at a very low cost. They're able to make a dramatic improvement in air tightness, but more importantly in comfort and livability of the house. That's really what we're thinking about. So safer, healthier, more comfortable, no mice. In fact, put it on your list when you're asking clients, do you have any bug or mice problems, rodent problems? We need to do a blower test on your houses because you need to find those holes. My whole family, I've done blower door tests on all their houses, almost always to solve mice problems, including Jim's house, the one I spoke about. Let's do a few minutes on Windows, not much, because you already know where I'm going with this. Let's make sure that we understand that everybody wants more windows. Then historically, windows weren't great from an energy perspective, nor were they great from a comfort perspective. And then you had condensation issues, and they have impacts on sizing. So we're going to say to you, find compelling reasons, find compelling reasons to go beyond the double glaze. And you'll notice that if I, in a standard, and it really doesn't change much, but this is all across the country, if I change from double glaze low E to tri-pane, 2 coats of low E, I get myself 6 gigajoules. 6 gigajoules that I can't get back. What a shame it would be if you're redoing windows tomorrow to doom them for another 30 years of an extra 6 gigajoules, knowing that Canada in the next 30 years needs to get dramatic improvement. This is 6 gigajoules that we just can't give up. But what else do you get out of triples? Well, I always like to say that's the equivalent, because 1 gigajoule one solar panel can generate about 1 gigajoule. My neighbor loved this because he's looking at solar and he goes, so if I do the triples, it's 6 less solar panels. He goes, actually, the solar panels are more expensive than the triples, so I'll go ahead and put the triples in. But what you really get out of this is less moisture on surfaces, allows you to get higher relative humidity, so you have no condensation. If you do it right, it has just the proper impact on solar gain to optimize the solar gain summer to winter, and it helps you manage comfort. There are really good, compelling reasons to go to triples. And then you're going to go with the yeah buts, but they're heavier. I get that. So we have to think about that in our quoting. Well, the attachment is a little different. Sure, they're more expensive, sure, but don't miss this opportunity. It's not cost effective to change windows energy efficiency alone, typically, unless you want to do a deep energy retrofit, cost effective energy savings, but it's certainly effective from a greenhouse gas perspective. And if you're doing windows anyway, don't miss the opportunity. Can I say it again? Don't miss the opportunity. Don't talk people out of triples. And I can actually give you hints as to how to do that. I just wanted to go to this one. Oh, I should go back. Making sure you're using the proper ratings with the proper solar gains. There's good choices to be made, so to make sure you don't overheat houses. I was out in Edmonton, and they're saying, wow, more and more people are doing air conditioning. Yes, because you've been putting in high solar gain glass. And the more efficient the house, high solar gain tends to overheat houses in the summertime. So all of you need to think about the solar heat gain coefficients. But I just want to show you the compelling reasons. Less condensation issues, which means the house is healthier. Avoiding cooling loads and better comfort in their house, and certainly quieter. My good buddy just did triples downtown Toronto. He goes, yeah, I did it for the noise. George, I had done the energy inputs for him. He could care less. What he was really interested in is the downtown noise in Rosedale. He wanted to get the triples. So just imagining those kinds of compelling reasons. So we've talked about basements and air tightness, and we've talked about windows. And Toby, you wanted to do a little bit on mechanicals.
Yeah, I just wanted to talk a little bit about some of the current equipment out there. In the past, a lot of these retrofit programs have focused on replacing fossil fueling equipment, and there's really not too many savings to be had there anymore. The regulations around gas furnaces and boilers have been steadily increasing over the years. So I believe now you're not even allowed to sell anything below 94% efficiency in Canada, I think. And
96 in Ontario. 96 in Ontario.
Is 96? Oh, in Ontario. Okay. So, going from a 94 or a 96 to a couple percent better, not really going to see a lot of change in efficiency or performance. So a lot of the discussion is going to hybrid systems that allow you to use a more efficient heating equipment, which would be essentially heat pumps. Air source heat pumps can do space heating. They can do hot water. There are also air to water units as well. They're still not that common, but available. And there's a lot of advantages to heat pumps. or a hybrid system, which we'll get into in a minute, because you get, obviously you get the energy efficiency, you get a reduction in carbon. They can do a lot with retrofits. There are equipment that can do zoning, you know, have different heads in different rooms or different zones of the house to allow you to control the temperatures. And good in retrofit, because you're not necessarily having to put duct work in if you have a radiant heating system, you know, boiler with rads or electric baseboards, and you want to improve the efficiency and save money. You can put in these mini split systems that allow you to put different heads, and then you're only running refrigerant lines through the house. You're not necessarily running ductwork. So there's a lot of options out there, and heat pump technology has really improved over the last 10 years, I would say, maybe even less than that, to the point where there was a question about, you know, can they heat in I think it was Northern Ontario or northern climates. And yeah, is there proof that they can heat homes in northern Canada?
And the answer is yes. And it's really important that people on this call go get over it. This is 30 years ago they couldn't, 20 years ago they couldn't, 10 years ago they could, and especially if you do hybrid, so you still have a little backup, you absolutely can work. There's a specific standard for cold climate heat pumps, so absolutely, it's there. And I would just say, Toby, before you get to your next slides, just put this in your heads. The most efficient gas furnace is 98%. For every dollar of gas you buy, you get 98 cents worth of heat. Sounds great, except compare it to the appliance to the right, air source or ground source heat pump. For every dollar of energy you buy, you get $3 to $4 worth of heat. Isn't that wild? Now, yes, it's a more expensive fuel, and in Alberta it might be generated with coal, but where you have a clean grid, we'd like to switch to electricity. There's tremendous advantage. And you would say, well, I can't necessarily do a heat pump for the whole house. I can at least do heat pumps through the mild season, if you will. And so they're 10 gigajoules or more. So I'll let you go back to it, Toby, and just keep that in mind. They're 300 to 400% efficient.
Mm-hmm. Sizing, of course, is very important. It's not just as simple as taking out your old furnace or air conditioner and putting in the same size furnace or heat pump. You want to make sure it's sized properly for the house. So we would recommend, heat loss, heat gain calculations, and that can also give you a lot of information into how the distribution system's performing as well. So your ductwork maybe is undersized, oversized, or combination with other upgrades or retrofits you're doing to your home. You're insulating the attic, you're reducing air leakage, you may be adding some wall or basement insulation. Those loads are going to go down. So now furnace or heat pump you had before is definitely going to be oversized, and so that could really help you get the most efficient system and get the most comfortable house as well.
And that's really the point here, guys. If you're switching out an air conditioner, switch it for a heat pump and size it's 25% overload. That may not going to do all of the heating for your house, but it dramatically reduces, and we can still do it cost effectively. So that's really cool. And there's a little example of improper sizing. Just in the interest of time, Toby, walk through this.
Yes. So it's just showing the difference in the hourly runtime of the equipment. So with a single stage system, you can see, it's running on sort of medium. Coldest temperatures, it's running quite a bit, which is great, but warmer temperatures, it's running only 10 minutes per hour. So what's happening during those other 50 minutes, right? The temperature is dropping in the house quite a bit. It's nice to have the equipment running as much as possible to have the heat being distributed better throughout the house as well. If it is running too briefly, only so many minutes per hour, it's not getting that heat to the far regions of the house. And in the case of air conditioning, it's not dehumidifying your air in the summertime very well. So you end up with a cold, damp house.
So if you're going to heat pump, then you go to two-stage. Homeowners want it anyway. You go to two-stage or multi-stage, and now you've got that done. So it's just that proper size. And this is a very cool, Enercan did a really interesting piece on this to figure out where we should be doing this. And top left, if you got an oil furnace, switch to a heat pump tomorrow. If you have bottom left, if you have electric baseboards or electric heat, switch to heat pumps now. And it works in all places. It works in greenhouse gases in all cases. The biggest issue is on the right. If you're switching from gas to heat pumps, in Ontario and in Manitoba and BC, it'll actually increase the dollars. So because gas is so inexpensive, and it ends up the homeowners are kind of worse off. That's why we like the idea of the hybrid. Use the heat pump when it makes most sense. And here's what's going to happen. The price of gas is going to go up, folks. We already know this, right? I think if somebody's Enbridge on the call should say it officially, but within 10 years, because of carbon taxes, assuming that stays, the price of natural gas per unit of energy will be basically the same as the price of electricity. So what a shame if you put in a heat pump, didn't put in a heat pump today, and a short 10 years from now, the rules change, and all of a sudden people go, wow, I wish I'd had a heat pump. Why didn't they tell me? So don't miss that opportunity. In some places, the unintended consequence, the bottom right, is in places that have, I would say, a greenhouse gas issue with their current, and I'm not being negative, by the way, don't get me wrong, I'm not saying anything negative, it's just the way historically the electric grid is run in those provinces. It has a big greenhouse gas impact. So we need to get the grid cleaned up while we do all of this work. So if the real lesson is heat pumps in all places instead of air conditioners, even if you don't run it in heat pump mode, just running in air conditioner mode, but at least you're setting up for when things are right so that you can get those savings. And that's really what you want to talk about, Toby, is just showing a bit of a comparison there. We'll just be a little mindful of time. We're okay. We got about 9 minutes left.
Okay. Yeah. Just quickly give you an idea what Gord was alluding to, the cost of the fuel, right? We have electricity. These are just the same units. So, electricity is coming, let's go straight to gigajoules, about $41 a gigajoule. Natural gas, $6 a gigajoule. So you can see it, it's cheaper. Propane, quite a bit more. But it comes down to the efficiency of the equipment. So you can still do an all electric solution like this with a heat pump and heat pump water heater. Yes, your bills are a little bit higher, or actually significantly higher than the natural gas solution. But if you do a hybrid system, which is really what we're getting at, it's, you kind of get the best of both worlds. You're getting a cost-effective system with a gas backup for those colder temperatures, and you're still getting greenhouse gas reduction as well.
And then as the price of natural gas, electricity changes, you've got dual fuel options. I just think it's the right way to go initially here. Don't miss this opportunity. HVAC guys on this call, do your homework. Figure out that, yes, there are heat pumps that'll work in every climate in Canada. Maybe it can't do down to -40. It doesn't need to. It's most efficient in the 10 Celsius or 15 Celsius down to -5 Celsius. That's a good chunk of your year, even in Edmonton. Let's get good greenhouse reductions there, and let's continue to use gas in the coldest of weather, if you will. Oops, just gonna watch that. There we go. And I'll just throw you a bit of an example of this. Here's a pretty nice house built in 2012. You go, well, can't do much to that. But this was a really forward-thinking gentleman that we know, Roger Groshwell. He was a heating contractor for years, bought this lovely home, and before he moved in, he said, I'm going to get a few things done. So in May 2021, beautiful house, right? In May 2021, before he moved in, he gave himself a 2-week period. He said, I'm going to address air leakage. So he had aero barrier done in the house, covered all the, it wasn't easy, but covered all the cabinets and flooring and so on, but at least they're out of the house, so we don't have to worry about the stuffy toys and so on. And so here's the 2 measures they did. They did air leakage, and they improved mechanical systems. They put in a hybrid heating system, 99% AFU furnace with a hybrid strategy with an air source heat pump, which also improved the air conditioning performance. They also put in a new high efficiency HRV, and they changed to a condensing water heater. They reduced the forced air duct leakage to improve comfort control using a technology called AeroSeal. Oh, and so they used this new technology called Aero Barrier. I won't dwell on it. It's just a way of finding all those small holes that are surprisingly difficult to find. And when you look at the difference between the original heat loss was 42,000 BTUs on the left-hand side there, and after it's only 32,000 BTUs. So was that a big deal? Yeah, that means the heat pump can be smaller. You're not going to change the size of the furnace, but I don't have to worry about a 4-ton heat pump or 3.5-ton heat pump. I can put in a 2.5-ton heat pump. So that was kind of cool. And it reduced both the annual space heating energy. Look at the dramatic reduction in that annual space heating energy consumption from 63 down to 20 gigajoules. And annual space cooling went down. And he's got it so it basically gives him roughly the same cost, that he runs his heat pump just when it makes most sense. So that's 69% reduction in annual space, and the bottom line, 57% reduction in the total annual energy use and greenhouse gas emissions for space conditioning and domestic hot water. When you think about Canada's commitments, if we could take with 2 measures, that's how dramatic this is, folks. If you fixed, and it doesn't have to be air sealing, if you do the windows in the basement plus, and so on, you do a couple of measures and then put in a heat pump. And the magic is when you do those measures, when you make a house tighter and you put in basement insulation, now the heat pump can get smaller and the heat pump gets to run for longer points of time. That's why we want to marry these up. That's frankly why Enbridge asked us to do this session. It makes a lot of sense to marry up your renovation work with the mechanical work to get you there. And then finally, just a couple of quick things. If you are re-siding, it would be, I'm going to put it this way, it would be criminal not to add exterior insulation. Now, if we went back to Toby's house, Toby, you're not tearing off the brick right at any time soon on the bottom, but on the top of Toby's house was vinyl siding. Could you ever imagine, excuse me, could you ever imagine a day when you're re-siding the top of the house?
Definitely. And I think would address a lot of our existing air tightness issues that I mentioned, and some issues with ants as well. They're getting
so
in the
if
house.
If you're doing a room, sure, tear off the drywall. You're doing a complete energy gut, do it. That's fine. But when you think about wall insulation, if we do the cavity, there's sort of the progression. Old walls are 12, new walls are 20, newest walls 24. Some would say I got spray foam at 35. But the actual effective R value of those walls, look at that. We went from a 2x4 wall at R12. We went to a 2x6 wall with R35 foam, but we only got an extra R8 out of it, the effective R value, right? You guys are all familiar with this. And that means in existing houses, we can't do anything about the framing. So we could think about jamming more insulation in cavities, but because of that effective R value issue, what we really want to do is put insulation to the outside. So if we take that old, let's say 1960s, 1970s, 80s, 90s house, 2x6 wall, and we simply do re-side it as we're re-siding, re-stucco. Maybe it's the double wide brick and we're going to do something to the outside, put stucco on, put 2-inch R10 of insulation on the outside. And it can be foam, it could be mineral wool, there's many choices. And it it increases the effective R value from, 16 to 25, a 70% improvement in the performance of that wall. It would be criminal if you're in the re-siding business not to add insulation on the outside. Yeah, but I got to build out the windows. Exactly. Pull the windows and put in triples. That's what we want to get to, is thinking about those kinds of elements. And really, Toby, our thought is let's make sure we're doing add energy efficiency elements to all of this work. I said insulating behind the walls in the Energy Star appliances. And considering tankless, if you're doing a bathroom reno, you're putting in a larger shower, let's go to a tankless water heater or an air source, heat pump water heater. And always thinking about ventilation. That's the back of your house, Toby, I believe.
Yeah, and I was just pointing out what you were just alluding to there, taking off the siding, and we have this little 4-inch bump out at the back of the house. And that's a problem. That's where the ants are getting in. That's where the air is getting in.
Right. And so here's what I'm saying to you. If you put 2 inches of foam on the outside wall, it saves 6 gigajoules. If you put insulation on the outside of a base wall, it saves 10 gigajoules. You do air sealing, it saves 10 gigajoules. You go to triples, it's 6 gigajoules. You put in heat pumps, it's 10 or 11 gigajoules. And our goal is to get to, from 106 was the average. We want to get down to roughly 50, somewhere in that range. That's where we want to get to. So what is practical? I can always do the ceiling. I don't think I can do the walls in most houses unless we're re-siding. Basements, a little tricky, maybe we can get there. We certainly can't do the slabs, but I can do tri-pane windows, and I would try to get air tightness. On the mechanical side, I got lots of things I can do. Heat pump, efficient backup, high efficiency, so on and so on. We can get this done. And then add solar panels to suit. That's where we want to get to. So in every renovation project, if we finish this off, do an energy assessment and then do blower door directed air sealing. More insulation properly installed, repair any moisture issues, continuous ventilation. You have to do an assessment of combustion safety. That's part of the energy assessment. I kind of glossed over that. So we're going to ask that in the question and answer, I bet. But if you're going to make it airtight, you got to get rid of chimneys, or at least you got to put in makeup air. And it's all based, the nice part is we have this metric, right? It's not a perfect metric, but we have a metric that includes the energy for heating, cooling, ventilation, lights and appliances, hot water, and our goal is to get it to zero as quickly as possible. We're at 108, 100 to 110 now in this 15 million existing houses. Let's take a chunk out of those every renovation project you do. I don't want you doing this, right? That's not the way we want to do houses. That's not the way to get our green. Well, go ahead and do it, I guess, if you got the money, but there you have it. And there are some great resources to this. Toby, you mentioned the Home Builders Association has a new great renovators guide, CHB Renovators Guide. Stacy, we'll make sure we include the link to that when we send this out, if that's okay. And then just to finish up, by all means, folks, sign up today for our own Builders Digest. So sign up, please, today. We're pleased to send regular information to you. And there's some other webinars coming up. I'm doing a little deeper dive on indoor air quality, and then Enbridge is doing a session on construction heat in May. So unfortunately, you have to listen to me in April, and then then the construction heat in May. And I will just say, and Stacy, you may want to come back on and thank folks for attending and see if we have. Look at that, we're 2:15 exactly where we're supposed to be.
We have a lot of questions.
We got some questions. Yeah.
Great.
Am I good to go? Questions?
Yes.
Yep.
Yes. Yeah, please start answering them, Toby. Yeah.
Okay. So one of them, Gord, is related to ventilation, and I think that we did sort of rush through some of those slides. So can you comment on the importance of ventilation, and also can smart air filters also clean the air and reduce sickness as they perform better than MERV 13? Just kind of comment on that ventilation versus filtration question, I guess.
Sure. So first and foremost, come to the April 14th session, we're going to do ventilation. But I really want to say this to you. All houses, new or old, tight or loose, need ventilation. How did we used to do it? We used to do it with windows. Even that old double-wide brick house had a ventilation system. It was opening windows. And I'm old enough to remember Mom coming in and saying, open your window an inch, dear, open your brother's window an inch, we'll leave them open all night long. The only time they got closed was when there was a skunk outside or if it was a really bad night. But otherwise, we used windows. And now we don't use windows. Our clients, if you said to your clients, oh, leave your windows open, noise, dust, security, energy costs, nobody's going to do it. So stop blaming, don't connect air tightness with the need for ventilation. All houses need ventilation. Every time you do a renovation project, I notice you don't have any bathroom fans. I notice you don't have a range hood. You don't have any ventilation in your house. You need ventilation. A good, quiet bathroom fan is a fine air quality device. Nothing wrong, as long as it's running more or less all the time. Well, I don't know where the air is coming in. Exactly. That's why you would prefer to go to a heat or energy recovery ventilator. But keep this in mind. Every house you go to, on your checklist, add it to your list of things to look at. Every house needs a ventilation system, and it's not because it's airtight. The nice part is, once you put in an ERV or HRV, or a good quiet bathroom fan, now you can go ahead and make the house as tight as you want, as long as you don't have any combustion issues. Now, in terms of filtration, nothing wrong with good filtration, but there aren't filters that practically in houses can do anything against the gases. They're really good at particulates, nothing wrong with that, but don't assume. So you really need both. High efficient particulate resistance, MERV 10 to MERV 13 on your furnace, and then ventilation. And the good news is it's 15 CFM per bedroom. It's not a lot of ventilation. You don't need a lot. That's a long answer to a relatively short question. But
no, that's good.
Coming session in April, we'll go through it in more detail.
I noticed a couple questions about this. Heat pumps, we're promoting, we're talking about heat pumps, but there are some issues with installers. You may have heard out west that some installers are finding that because they're trying to meet the requirements of certain programs, it's causing problems and grief for their customers. So they're getting out of the business of doing heat pumps. And also HVAC industry trade people. Is there any training going on for the HVAC industry to install and maintain, newer types of heat pumps?
And the answer is, I'm right now writing a program for HRI on exactly this. How do we deal with heat pumps? So HRI, the Heating, Refrigeration, Air Conditioning Institute, has stepped up and said, yep, we need to promote. And with the help of municipalities and utilities, frankly, they are both gas and electric utilities. They are showing one how to sell them and then getting the technical expertise to install them. And there's no doubt, he's quite right. There are problems when you're trying to meet specific programs. Must meet at least, 75% of the heating load. That's not practical in some areas. We shouldn't stick ourselves to that. So we need to think about the size of the ductwork that's in the current house. That's why you want to do a couple of other energy efficiency measures. If you got the air tightness done, you got the windows done, or you got the basement done, 2 out of those 3, now the heat pump does make even more sense. Smaller heat pumps make even more sense. So yes, there's training coming. Watch for it. HRI, go to HRI's website. 2, talk to the manufacturers. And 3, partner up with an HVAC contractor, one who's comfortable with this.
A couple questions about windows here, Gord. We have a good suggestions from Jeff Baker here. It says, don't pass up 2 low E coatings on a triple. A single low E coating is a wasted opportunity.
Thank you. That guy, Jeff, what does he know about windows? For those who don't know, Jeff is undoubtedly the preeminent authority on windows in Canada. Thank you, Jeff, for adding that. I think what he said, if I got that right, always go to 2 coatings, right? It's so cost effective. I'm going to say it's pennies a square foot. Jeff may correct me, but it's such
improves your U value, right? And lowers your solar heat gain.
Both, right? Solar gain and U value. It's a really good. Thank you, Jeff, for that.
Yeah. A couple other questions more about retrofitting windows, Gord. And there's, I think some of the participants are just sort of asking about whether, instead of full frame replacements, what are the effectiveness of just doing a triple pane insert in an existing window frame, or even a retrofit where you would add a layer of magnetic, I don't know if it's acrylic sheeting or something like that, just to make a double into a triple pane.
Yep. So I'll answer the second one first. We used to talk about those magnetic inserts a lot, or at least retrofits. I have no problem with them. I just can't seem to find them much in Canada anymore. They absolutely help with, let's say, your old California sliders or McPherson. I think they were called Pearson windows. Mm-hmm. By all means, in the short term, you should do that. I just haven't been able to find them of late, but if they're there, great. In terms of the other question, by all means, you should do the full frame tear out, because then you get to treat the rough stud opening. But that said, if, again, from a cost and aesthetic, sometimes you go, I just don't want to have to do trim and paint and so on. I'm just going to do the insert. In which case, that's fine. Let's just make sure we do a blower door directed air sealing, and make sure that we air sealed around the frame, the old frame. And then we're okay.
There's some practicality issues with those. Obviously, you're taking them on and off. You may not be able to open the window, during the winter and things like that.
Well, that's the magnetics. I'm thinking the insert of the triples. Yeah, the insert of the triple. And you do lose glass area, right? When you go to an inset, you lose glass area.
Yeah.
But if it's a cost issue and a renovation issue, I just don't want to do that, because if you do a full frame tear out, now I got to retrim the windows, and I wasn't planning for that. So I'm okay with the inset, as long as we do proper water management outside and proper air sealing inside. Good. Any others?
There are some others. Yeah, I'm just sort of trying to categorize them. There's another one about ventilation, HRV, ERV. So at what air tightness do you need an HRV or ERV? So a bit of a tricky question, but what's your take on that?
Well, here's what we know. There's actually a pretty good calculator on this. We've done a fair bit of work on it. Enbridge has well, I developed a little calculator for Enbridge off of, I think it's called Red Calc off the internet. What we would say is, for sure, if you're getting below 3 air changes, it really starts to make sense to get to an HRV or ERV. But I want to remind you, this is not a decision of no ventilation versus ventilation. All projects, you need to leave the homeowner with ventilation. Let me say that again. Every renovation project you do, when you leave, one of the things you should say to me, and remember, that fan there, or that ERV there, is your ventilation system. It should run for significant periods of time every day. Why? Because I'm interested in your health, and you're not opening your windows unless you're telling me you're going to open your windows, or the days you're not going to open your windows, I want you to turn on this fan. That's been a national building code requirement since 1990 anyway. So all houses need ventilation. At what point does it make energy efficiency sense? Cost savings, well, certainly under 3 air change, but you just saw we need to do the greenhouse gas reduction. So an HRV or ERV over any other choice is another 3 to 4 gigajoules. So it's a pretty simple 3 to 4 gigajoules. 3 to 4 solar panels. Go ahead and put it in.
Yeah. I'll comment on my house, which is not at 3 air changes. It's a bit above that, but we definitely noticed in those shoulder seasons, the spring and the fall, that the air in the house gets very stuffy, kind of damp, and you start to smell things that you didn't smell during other parts of the year.
Let's not tell them how many kids you have.
So, yeah, 3 kids, 2 dogs.
Other questions?
Okay, here's a building science one. I haven't really had a chance to think about it too much, but so it's from Phil LeMay, and I apologize, I haven't been giving people's names here. Phil LeMay is an HVAC contractor, works in new housing, net zero homes, having lots of issues with moisture and dryness. So the ERV is installed with smart duct systems, and it's very, very dry in the winter. They had to install humidifiers to help with issues. Is this a ventilation issue?
Well, again, this same mantra. You need ventilation regardless. I get this. Well, you don't want a house too dry, so turn off the HRV in the winter. Oh, you don't want a house too moist in the summer, so turn off the ERV in the summer. No, you need to make a mechanical system that includes the capacity for continuous mechanical ventilation. Now, if you have too much ventilation, that is more than what the occupants are generating. So we need to think about where are the moisture sources. It's the people that are generating the moisture. If you have a 10,000 square foot house with 2 people, you need to add a humidifier. I'm sorry, because you're just not generating enough moisture. So it's absolutely nothing wrong with putting in a humidifier to keep the house 35 in the winter, up to 35. And putting in an ERV that ventilates continuously. ERV helps reduce the amount of moisture that it takes out of the house. And in the summertime, the ERV reduces the amount of moisture that comes in the house when you ventilate. So ERVs are a great choice to help manage moisture, but they're not dehumidifiers and they're not humidifiers. They're simply reducing the load on the humidifiers and reducing the load on the dehumidifiers. I'm going to say more and more, the net zero houses, because of the lower run times of air conditioners, all mechanical contractors will be, and almost all clients, maybe not Alberta, where it's Saskatchewan, where it's really dry in the summer, but everybody's going to be putting in whole house dehumidifiers because your air conditioners just aren't going to run very long. Your sensible loads, the windows are better, the walls are better, the air tightness is better, the sensible loads are way down, and the latent loads are on their way up, people showering, cooking, and so on. So you're going to be putting in dehumidifiers in houses. So here's what you're going to have. You're going to have a heating system. What? You're going to have a ventilation system running all the time. You're going to have a humidifier running in the winter, perhaps, depending on moisture loads of the house. You're going to have a dehumidifier running in the summer. And then now and again, you're going to have a heating and a cooling system come on. That's a heat pump in both cases. In other words, heating and cooling is going to become intermittent. The only continuous load in a house, let me say this, the only continuous load in a house is actually the ventilation. It's supposed to run whenever people are breathing in the house. That's what you need. And every other decision is based on temperature set points and so on, but the ventilation should run all the time.
I just want to add to that. It's likely not, I guess the ERV is likely not over drying the house, but you can adjust how much the ventilation system runs too,
Absolutely.
right? Just for
Nothing wrong.
personal,
Absolutely.
yeah, personal
We
preference.
size the ventilation, 4-bedroom house, we size it for 5 people. Well, if there's only 2 people living in a 4-bedroom house, the ventilation system does not need to run at the 5-person rate. So if it went in at 75 CFM, we only need to run it at 45 CFM, and so put it on a timer or so on. So adjust the ventilation system. Builders have the requirement to provide the capacity, but if the occupancy load is lower, by all means adjust the ventilation rate. Thanks, Toby. That's a good point. We're probably about done, are we? Stacy, you probably need us to
Yeah,
go
I don't
off.
know, Stacy, do we have time for one more question? Can we push past 2:30?
Well, I'm trying to copy as many of the questions that are
good.
out there because you aren't going to be able to answer them all right now. So we're going to have to address them after this webinar and put that on
We do that.
the.
I'll give a little. I'll either give a link or resource, or I'll answer them in person. Toby and I'll answer them in person.
Work on it.
Not a problem.
Yeah, so
Okay.
I've copied all the questions and then you guys will answer them and they'll be sent as a whole package with an email. So sorry about that, guys. Your questions were really detailed, and with the guys talking the whole time, it was really hard for them to give the attention that they deserved because they were more than just a yes or no answer. So they have all
most of those questions. Many of those questions, Stacy, will be answering in the April 14th session. The ventilation indoor air quality questions will be answering in April 14th.
Okay.
Well, let me say thanks on behalf of Building Knowledge, but more importantly on behalf of Enbridge. What a great partner they are in the industry, working really hard to help us through these transitions. I just need you guys to think. There's 15 million houses at 100 to 110 gigajoules, and every project you do, every renovation project, you got to go looking for 5 to 10 gigajoules, right? That's what we need. Every time you're in that house, let's look for 5 to 10 gigajoules or more to help Canada with our commitments to get to reduce greenhouse gas emissions. That's the urgency. That's the priority.
Yeah, I'll just add about, there were a couple of questions about embodied carbon, and I'm sure there's some webinars coming up on that people can listen in on, because that is a new and emerging issue that's that can outweigh the operational carbon savings. So
Right, absolutely. Good. Thanks again.
Thank you for attending, everybody.
And Stacy, they're going to get a Survey Monkey.
Yes, they are.
And we'll be sending out the presentation.
Yes.
Thanks, Kay.